Hi, everyone. Before I start my talk, I want to know how many of you have done 23andMe? How many of you have been disappointed by 23andMe results? Like, they tell you, oh, your prediction is, we are 3% confident that you're coming from like the East Africa or West Africa or Southern Asia or any part where you end up not coming from there. Okay, that's where my work comes in play. So all these, the reason why you have this is because there has been an overrepresentation of people from white ancestry in medical genetics, and this is where they use the data to put all the prediction tools that you have. And this overrepresentation has been just increasing over time. And the bad news is European population represents only 13% of the world population. So you can see that they're taking like a very small minority to extrapolate to the whole world. And the big problem is that when you do that in the world of genetics, you build the tool, and when you extrapolate the tool to all the ancestry group, the prediction is really bad, as you can see on the other part of the plot there, where I show that if you build a tool for which we call population risk score to predict the risk of diseases using European population, you have a very amazing accuracy in predicting that. But when you take that tool to apply to other population, it just falls apart. But okay, everything is not that bad. Recently, there has been a lot of biobank that has been developed over time, and because they know that they have to include a lot more people, those biobanks have been really working hard to include minority. And I'm just showing you a couple of biobanks here where, like, for example, the Medium Veteran Program, which is the VA, a biobank for VA in the US, but also outside of predominantly white country, the biobank has been developed, like the Mexico biobank, the Japan biobank, and the Uganda biobank. So all of these efforts have the objective of improving our understanding of diseases across minorities. So my work is to gather all these biobanks and try to put them together and understand the genetic architecture of diseases as a population and build a prediction tool that will not disappoint you anymore. So, so what we do is, so the objective, I'm just going to show you a little bit of framework of what I do. So basically, it's taking all those biobanks and combine and pick a phenotype there. Like, for example, things I mentioned, I'm currently focusing on is cardiovascular disease. So I'm going to look at coronary artery disease in those biobanks and look at the genetic risk of coronary artery disease using what we call genome-wide association study. But there are other type of exciting things. Like when we talk about heart disease, we see clinical manifestation of the disease, but there are places where we can see things before it happens, which is when you go to do cardiac MRI, they have a picture of your heart. So basically what I'm interested in doing is using machine learning to extract some of those anatomical features, like the diameter of the aorta, to be able to say if the diameter of the aorta is getting larger and larger, what are the genetic predispositions to that, and how I can use that to predict aneurysm. So that's what I call intermediate phenotype, which we try to understand the genetic architecture of those phenotype. Of course, always important to try to expand our discovery to people from minority background or people that was historically underrepresented in medical genetics. Use those tools to develop population, what we call population risk score, for example, to predict the risk of diseases, like how we can use the genetic of aorta diameter to predict the risk of aortic aneurysm. And then lastly, because we know that people that are smoking or hypertension are the risk factor for having aneurysm, one of the things I'm interested in doing is like, how can I take the genetic marker that predisposed to hypertension to understand the causality with aneurysm, and how can we use that in the end to develop some new therapeutic targets? The whole point of this is to create new tools to improve precision medicine in the way that is transferred across population and develop new drugs. Thank you.